Now, we have learned that when light enters from one transparent medium to another transparent medium of different refractive index, it suffers through refraction. So you remember how light refracts when passes through a rectangular glass slab. Well, you are right. A glass slab has two parallel refracting surfaces. In that case, it is observed that the emergent ray is parallel to the incident ray and is laterally displaced. But the question here arises is, what if the two surfaces are not parallel? Yes, we're talking about a transparent prism. Let's first know about a triangular glass prism first. A triangular glass prism consists of two triangular bases and three rectangular lateral surfaces. The three surfaces are inclined to each other. The angle between its two lateral faces is called the angle of the prism and is generally represented by the capital letter A. After knowing about the triangular glass prism, let's perform an activity to study the refraction of light through it. Now for this activity, what we need is a drawing board, a sheet of white paper, a triangular glass prism, a pencil, a measuring scale, 4 awl pins, board pins, and a protractor. Now with the help of a board pins, fix a sheet of white paper on a drawing board. Next, what you do is place a glass prism at the center of the paper in such a way that it rests on the triangular base. With the help of a pencil, trace the outline of the prism. Now draw a straight line PE inclined to one of the refracting surfaces of the prism. Fix 2 pins on the line PE. Mark the points as P and Q respectively. From the other face of the prism, look for the images of the pins fixed at P and Q. Fix 2 more pins and mark them R and S respectively. The pins should be fixed in such a way that the images of the pins at P and Q are the pins R and S lie on the same straight line. Now remove the pins and the glass prism. Extend PQ to meet the boundary of the prism. Mark the point on the prism as E. Join the points R and S. Extend the line backwards to meet the boundary of the prism at F respectively. Now join E and F. Now at this point, E and F draw perpendiculars to the refracting surfaces A, B and AC of the prism respectively. Mark the angle of the incident, that is, angle between the incident ray PE and normal NN prime. The angle of refraction R, that is, angle between the refracted ray EF and normal NN prime, and angle of emergence E, that is, angle between the emergent ray SF and normal MM prime. It is observed that during the activity, the light suffers refractions 2 timers. Now first, while entering from the air glass, at the first surface AB, where it bends towards the normal, second at the second surface AC, where it enters from glass to air and bends away from normal. Now with the help of the protractor, measure the angle of incidence and the angle of refraction at each refracting surface of the prism. Repeat the activity for different angles of incidence between 30 degrees and 60 degrees respectively. What do we observe? Yes, the angle of incidence and the angle of refraction at the first refracting surface are equal to the angle of incidence and the angle of refraction at the second refracting surface. It is similar to the refraction of light by a rectangular glass slab. But since the opposite faces of the prism are inclined, not parallel, the light bends in a different direction. Now extend the incident ray in forward direction. This is the actual path the light would have traveled to, if not deviated. Extend the emergent in backward direction until it intersects the extended incident ray. Now measure the angles between the 2 rays. This is the angle by which the light ray has deviated from its original path and is so called the angle of deviation. Now it can be simply defined as the angle between the incident ray and the emergent ray. So what we've learned today is a triangular prism consists of 2 rectangular bases and 3 rectangular lateral surfaces. The 3 surfaces are inclined to each other. While traveling through a prism, the light suffers refractions 2 times. The angles of incidence and the angle of refraction at the first refracting surface are equal to the angle of incidence and the angle of refraction at the second refracting surface. The angle of deviation is the angle between the incident ray and the emergent ray. Thank you so much for watching and keep learning.